Hello, so we're going through this problem that says using either contraposition or contradiction prove that for all integers n, if n cubed plus 5 is odd, then n is even. Okay, so it says contraposition or contradiction. Oh, by the way, this comes from Discrete Math 137 at Macquarie 2015 Session 2 Exam. Question 1F. Okay, so it's asking you for either, so let me just show you both and you can choose the one that you're most comfortable with. So what's contraposition? So contraposition is taking the contrapositive of the statement and giving a direct proof of the contrapositive of the statement. And contradiction is assuming the statement's not true and then deriving a contradiction. Okay, so contraposition. Let's try a contraposition. So the if is like n cubed plus 3 is odd, then n is even. So the contraposition would be trying to prove if n is not even. So if n is odd, then n cubed plus 5 is even. Okay, and so we want to do this for all integers n. Okay, so let's do that. So let n be any integer, and then assume n is odd. Okay, so if n is odd, then well, n cubed is also odd, and you might want to show that. So maybe n, you can write n is 2k plus 1. So this is this is the definition of odd. So it's 2 times an integer plus 1. Okay. It's somewhat awkward because if you use that to show n cubed is odd, you might have to know how to cube this. Which is not so important. But you know, if you know modular arithmetic, you can do this mod 2 and it's just 1 cubed. But you know, so this is a minor distraction because this is not really about cubing stuff. So this is, you know, so this is 2k cubed plus 3 times 2k squared plus 3 times 2k plus 1. Which, you know, all of these things have a 2 in it, so it's 2 times, you know, 4k cubed plus 6k squared plus 3k plus 1. So this means this is odd. Okay. And an odd plus 5 will be even. So another way of saying that is n cubed plus 5 is equal to this number plus 5. So it's equal to 2 times, so let's call this m. 2 times m plus 5 plus 1. So 2m plus 1 plus 5. And that'll be 6. So this will be equal to, so, you know, 2m plus 6, which is equal to 2 times m plus 3. So this is the definition of an even number, is that it's 2 times some whole number. So then we just showed that n cubed plus 5 is even. Okay, so that's what you would do by contraposition. Okay, so now let's go to the part 2 of this question. So we're still on the same question, and maybe I could rewrite for you the contrapositive proof without the distracting business of cubing n. So, you know, let n be any integer and assume n is odd. Okay. Then, you know, and depending on your context, some of these claims may not need proof, and this is more to illustrate that you understand the concept of a proof rather than you know, necessarily know any number theory, so, or algebra. So then n cubed is odd. Okay. And if n is odd, it means 2 does not divide n. So 2 will not divide n times n. And nor will it divide n times n times n. So since it doesn't divide any of the n's, and 2 is prime, it can't get into 2 cubed. So then n cubed is odd. Okay. And then since 5 is odd, an odd plus an odd is even. So then n cubed plus 5 is even. Okay, and that's sort of, and that'll be the end of the sort of the proof, if you didn't have to really justify each step in that kind of way. Okay, so let's move on to the contradiction. Okay, so contradiction is basically suppose that the claim is false. Okay, so supposing the claim is false, especially A implies B, is basically supposing A is true and then supposing B is false. Okay, so So if the original statement was if n cubed plus 5 is odd, then n is even. So assume n cubed plus 5 is odd. Okay. But so n is not even, so the conclusion is false. Not even. Okay, so we're proving something for all n. So we're showing that so there exists this n. Okay, so there exists this n for which that's false. Yeah, so let me just say that again. So the original statement was show that so for all n, if n cubed plus 5 is odd, then n is even. So the negation of that statement would be there exists some n for which n cubed plus 3 is odd, but n is even. Okay, so there exists some n, and there exists a number such that the assumption is true but the conclusion is false. Okay, so that's the negation, and we want to use these facts to derive a contradiction. Okay, so if n is not even, then it's odd. Okay, and n cubed plus 5 is odd. So if n is odd and n cubed plus 5 is odd, well, what could the contradiction be? So n is odd, and I mean it's kind of, you could do something very similar to the other ones, because maybe that's why you had the choice. It involves very similar kind of logic. So if n is not even, it must be odd. Then n cubed is odd, as we discussed before in more than one way. And also so 5 is odd, so therefore an odd plus an odd is even. But we assumed that it was odd. So a number cannot both be even and odd, so this is a contradiction. Hence, we have a contradiction. Okay, so those are the two ways of the exam wants you to do it, and both ways are essentially the same, because I mean, if you did it by contraposition, you would just not say this. It was a contradiction, because n cubed plus 5 is even would already just be the negation of the assumption. Okay, so it seems in some cases a contradiction just has an extra assumption than the contraposition, but you'd still sometimes like the contraposition because it focuses on exactly what's needed in the logic and nothing extra.